Okay, this question been sent is about differentiation rates of change. So here we've got our manufacturer produces. So we haven't got figure 3 here, but I believe that it's a cylinder that looks like this with a base radius of x. So this is our x millimeters and a height of h. Given that the volume of each tablet has to be 60 millimeters cubed, express h in terms of x. Okay, so we in this situation here, we want to most likely you want to write down essentially the formulas for the 3D shapes that you're going to have to memorize. So for the cylinder one, it's just the area of a circle. So we're going to start with the volume because we're given the volume in the question. So the volume is equal to essentially the area, or the cross-sectional area, times the height. In this case, the area is going to be the area of a circle because it's a cross-sectional area. So the volume is equal to pi r squared times h. And then it tells us in the question that the radius is equal to x, so it's pi x squared h. And then it tells us the volume is also equal to 60 millimeters. Here I would just double check that the units are all the same, because you might have something meters, for example, or centimeters. But here we can see millimeters, millimeters, millimeters cubed, so it's all fine. We can continue as we are. So it wants us to express h in terms of x. So here we just want to make h the subject. So here we've just got pi x squared times h, so we're just going to divide both sides by pi x squared. So h is equal to 60 divided by pi x squared. And that's your answer to number 1. For number 2, show that the surface area of a tablet is given by 2 pi x squared plus 120 over x. So for this one, we need to find the surface area of the sphere. So the surface area, not the sphere, sorry, the cylinder. So the surface area of the cylinder. So that's equal to, so the surface area is essentially the area, the area of each of the shapes essentially. So here you've got the circle, but remember on the other side you also have a circle. So it's going to be 2 times pi r squared, because you have an area at both sides, and then you have this area here, and this is 2 pi r times essentially your height here, your length, so 2 pi r h. This is something that you'll have to remember. So if you're really struggling with this, make sure you flashcard it so you can remember them. It's the surface area of a cylinder is given by, so it's 2 times pi r squared plus 2 pi r h. So again, if we substitute it in our values, so we know that the radius is x, so it's 2 pi x squared plus 2 pi x h. Now that gives us the area, but if we notice on the next term here, we have got we've got an h here, and we notice on this one there's no h. So that gives us the indication that we need to replace in it, and it sort of makes sense from part A in terms of we've found h in terms of x, so that suggests that we're then going to replace h in this equation. So that means that A is equal to 2 pi x squared plus 2 pi x times h, which is 60 over pi x squared. From here we can do, it's just algebra from here, so it's 2 pi x squared, so we're going to do 2 times 60, which is 120. The pi's cancel because it's times and divide, and then we've got the x here, so it's x at the top divided by x squared, so that means it's just going to be 120 over x, and that gives us our answer to part B, which is what we want. The manufacturer needs to minimize the surface area of the tablet. Use calculus to find the value of A for which A is minimum. So in this case, if we're trying to find the minimum value, we're going to differentiate. So we're going to find dA dx. So the first thing we do is we differentiate. Well, the first thing that I would do here is actually rewrite this equation, just to make sure, not for the first term, but for the second term. So it just ensures that we don't make a mistake. So this is the same as 2 pi x squared plus 120 x to the power of minus 1. When we differentiate the rule, so if you have y equals nx, oh, hang on, we should do it the other way. So it's ax to the power n, y prime is equal to nax to the power n minus 1. So it's times by the old power reduced to power by 1. So here it's 2 pi x squared. We're differentiating the x. Remember, the pi is just a number, it's just a constant, so we don't do, essentially it stays like a number essentially. So if we do 2 pi times 2, that's equal to 4 pi, and then we reduce the x by 1, so it's 4 pi x. And then the next term here, it's the 120x to the power minus 1, so we times by the old power, so that's minus 120x to the power of minus 2. Now if it's a minimum, therefore the a dx must be equal to 0. So whenever you're finding a minimum or a maximum, the a dx is equal to 0. So therefore we then replace dA with the a dx, with 0. So that's equal to 4 pi x minus 120x to the power of minus 2. And the goal here is to solve for x. In this situation, I usually just rewrite it. So this time I essentially put it back into fraction form, and then I can solve from here. So the first thing I want to do is get rid of that x squared. So I'm going to times everything by x squared. So 0 times x squared is 0. 4 pi x times x squared is 4 pi x cubed minus 120. Then from here we just rearrange, as 120 equals 4 pi x cubed, then it's 120 over 4 pi equals x cubed, so x is equal to the cube root of 120 over 4 pi, and then we just plug that value into our calculator. So 120 divided by 4 pi, all cube rooted, is a value of 2.12, so 2.12. I suppose we could do 2.122 to 3 decimal places. So try and keep, you don't need to write the whole thing out all the time, but try and keep a reasonable amount of significant figures. So x is equal to 2.122 millimeters. Calculate the minimum value of a, giving an answer to the nearest integer. So for part D, what we do is we take our x value that we found, we know that's the minimum value, and we're going to substitute that into our a. So for part D, we know a is equal to 2 pi x squared plus 120x to the power minus 1. We just substitute in our value. So 2 pi 2.122 plus 120 2.122. In this situation here, I'd have your answer from before and just use the answer function to plug it in, because that makes it a more accurate value. So here, if we'd use the answer function in your calculator from your previous one, that would give you a, it's 2.122 squared, that's the power minus 1. So just double check that everything is fine. 120, 2.1, answer to the power minus 1, plug that in, we get an answer of 84.84. Then we go back to the question, and it says to the nearest integer, so this to the nearest integer, that is equal to 85 millimeters squared. So that gives you your part D, and then part E, show that the value of A is a minimum. So to show that the value of A is a minimum, we need to go back to, we're going to differentiate again. So this is where you use your d2a dx squared. So we start off with our original 4 pi x minus 120x to the power minus 2, and then we're going to differentiate. So d2a dx squared, so 4 pi x will go to 4 pi, and then it becomes, so minus 120 times minus 2 is equal to 240, so plus 240, so plus 240x to the power of minus 3, and then we get our x value, which was 2.122, or whatever our answer is, and then we plug that into d2dA dx squared is equal to 4 pi plus 240 2.122 to the power of minus 3. Plugging that into our equation gives us an answer of 37. Now the actual number here doesn't matter, but what is important is that d2a dx squared is greater than 0. So therefore it shows that x is the value for the minimum. So therefore A is the minimum because we've used the lowest x value for our area. And that's it. That's all you had to show for this question.